Hello students, welcome to samclasses. Now today in this video, we'll be learning about the chapter relation and functions. So these three combined will be studying it, sets, relations and functions. The chapter is of very good weightage, good importance for the COMEDK. Now we didn't get the exact marks like the weightage, but approximate you can understand as sets contains around 3 to 4 questions. Okay, on an average 3 to 4 questions you can take it, sometimes very rare 5. We can't be very reliable because the book which we are following is not that reliable. Students understand, the book which is available right now in the market for COMEDK is only one book, and that is equal to, that is in Amazon, okay, in Flipkart also, by MTG, chapter wise and topic wise. Okay, but that is not reliable because the total marks of the math section, if you see, it's more than 60. So, but okay, still based on that, so we have this data. The chapter is very good. We have taken a parts of the video from the KCT concept also, the concepts which were similar, which were important, because a lot of KCT concepts are important and they're directly taking into COMEDK. The questions are directly pulled from KCT into COMEDK. Okay, so understand very properly, and we have less time to provide you with the crash. So we have taken a part of the video from the KCT and we have made a separate playlist. Okay, we didn't just say it, okay, you just go and study from the KCT this concept. Okay, we have taken whatever was needed from that part and we have merged, and we have given somewhere a bit extra, somewhere not a bit extra, somewhere if it was enough we just kept it like that. Okay, change the thumbnail, made it into a separate playlist, and we are providing that to you. Okay, so if students some are of KCT, they'll find a lot similar with the concept, so you can go like with a 2x speed, just go through, zoom in. Okay, just go through, not zoom in, let's just go through and have an idea whatever the concepts are. For the students who are doing it for the first time, okay, understand each and every concept properly, make short notes, and once you have made the short notes, you can upload that short notes in our website, onlinesamclasses.in. We do grade your short notes, we do check your short notes, okay, and provide you a reliable feedback. Okay, so that's it. Start, work hard. We'll provide each and everything. By 10th, we'll be done with maths and physics. 11th is your first mock, 12th is your second mock, 3rd is your revision day, 14th, you hit for the exam. Best of luck. Let's start the chapter. So first, the chapter we read previously about sets. So we learned what is set, different types of sets, the different operations we can perform, union, intersection, subtraction of sets. Then apart, then apart from that, now we're learning what is Cartesian product of sets. What we're learning? What is Cartesian product of sets? So in Cartesian product of sets, let's say they have given us two. One second, student. They have given us two sets, set A and set B. Okay. And the first condition that what they have said is these two sets are non-empty sets. So first, two non-empty sets. Okay. Now, the Cartesian product A cross B. What is it defined as, student? The Cartesian product A cross B. Let's say we have elements A, B, and C here, and we have elements 1, 2, and 3 here. So the Cartesian product A cross B is defined as all the kinds of mapping that we can do from the set A to set B. Okay, all kinds of mapping. Now, mapping means attaching one element of A with the other elements of the B. Now, so what are the different? A can be attached with 1, mapped with, okay, A can be mapped with 2, A can be mapped with 3, B can be attached with 1, we can attach B with 2, B with 3. Similar way, we can attach C with 1, C with 2, and C with 3. Okay, so this is known as the Cartesian product of A cross B. Okay, this is the definition of the Cartesian product of A cross B, students. Okay, so let's again understand the Cartesian product A cross B is defined as, okay, A cross B is defined as, that is equal to, let's say, P comma Q, where P is belonging to A and Q is belonging to what? The other set B. So one element we are taking from A and one element we are taking from B, and we are forming a Cartesian product. Okay. So this one is very clear to all. What is A cross B? It's nothing but the mapping of each element of A to every other element of B and writing it down. So that is called A cross B, okay, or the Cartesian product of A and B. Pretty simple as that. Now, is A cross B the second thing that comes in mind is A cross B equal to B cross A? So let's try it and check it out. So B cross A, what will happen? The elements of B will come first and the elements of A will come second. So here order matters. In the sets when we were doing students, order didn't matter. Here order matters. So A comma 1 and 1 comma A is entirely different. So B cross A is not same in this case as A cross B. Okay. Now, so it will be 1 comma, what do you say, B, 1 comma C. It will be 2 comma A, 2 comma B, 2 comma C. Okay. And in similar way, 3 comma A, 3 comma B, and 3 comma C. So this is the basic concept of Cartesian products. Okay. So we have taken two non-empty sets and then we did a mapping or a matching. Okay. Between the, what to say, A and B, where A cross B is defined as P comma Q, such that P, the first term of the A cross B, is coming from the first set and the second term is coming from the second set. Okay. So this is the, what to say, Cartesian product of A cross B or two non-empty sets. Now, coming towards, and the order here matters. Okay. The order A comma 1 and 1 comma A is entirely different. Okay. Because the first element here is 1 A and the first element here is 1. So both are entirely different, student. Okay. Now one second thing which comes here is, now if I know the number of elements in A is equal to P and the number of elements in B is equal to Q, so number of elements in A cross B will be how much? Very simple. It will be P cross Q. Correct? Simple as it is. Nothing difficult in this. Okay, because we are multiplying. We just now saw A if it is 1 and 2, B if it is 3, 4, 5. So number of elements in A is equal to what? 2. And the number of elements in B is equal to what? 3. So the number of elements in A cross B will be how much? 2 into 3. Simple as it is. So that will be equal to 6 students. Okay. Nothing more than that. Now, let's see the next part. So here we have the clarity. Now coming to very simple questions. Let's see one simple question. What they have given is, if we know that the ordered set x plus 1 comma y minus 2 is equal to 3 comma 1, we have to find the values of x and y. Now I told you order matters. The first element this side will be equal to the first element this side. So what do you get? X plus 1 is equal to 3. So x is equal to what? 3 minus 1, that is equal to 2. And similar way, y minus 2 is equal to 1. So y is equal to what? 1 plus 2, and that is equal to 3. Pretty simple as it is, correct? Okay, very good. Now let's see some other examples also. Now a simple question, let's take it. Question number 2, what we are taking is, if A cross B is given as P comma Q, P comma R, M comma Q, and M comma R. Okay. So this is given to us. Now they're telling that find the set A and set B. So I already told this is what A first and then cross with B. So whatever the first elements are coming, that is belonging to A. So P and M are only coming. So these two elements belong to A, and whatever the second elements are coming, that belongs to B. So Q and R, that's it. Pretty simple. So everybody understood the concept of Cartesian product of sets, correct? Now let's come to the second part. What is a relation? Okay. So we all know what is a relation, correct? So let's see in mathematics, what do you mean by a relation? So a relation has a very simple and what do you say, a definition. So what is that definition is? Okay. So we did A cross B, correct? We took two non-empty sets. Two non-empty sets we have taken here. Two non-empty sets, A cross A and B, and we did their Cartesian product, correct? We did their Cartesian product. So every subset of A cross B, okay, every subset of A cross B, student, is a relation, okay, is a relation, correct? So what is the definition of the relation, student? That whenever we have two non-empty sets, A and B, we do a cross product, A cross B, then whatever number of subsets that we generate, all the subsets are a relation. All the subsets are a relation. Okay. Now, in relation part, we have two important things. So, whenever a relation is there, let's say it has two elements. One, let's say like this, A and B. So A is like 1, 2, 3 and B is like 4, 5. So you're matching like this, 2, 5. Okay. So 1 comma 4, cross product 1 comma 5. Let's say 2 comma 5 and 2 comma 4, 3 comma 4 and 3 comma 5. Now the elements which are belonging to the first set, they are known as what? The domain. And the elements which are belonging to the second set, that is known as what? So domain is nothing but the first set A and codomain is nothing but the second set B. Okay. So whenever we have two non-empty sets A and we do A cross B, then whatever the subsets we generate, these all subsets are a relation. That is one thing. Coming to that, after that, what is domain? The elements of the first set is called domain and the elements of the second set is called the codomain. Okay. It is also called as the range. We'll see what is the difference in the range and the codomain. Now we know range is always less than equal to codomain. So don't worry about this. We'll again understand what do you mean by this. Okay. We'll see with an example. We'll understand what they're trying to say about this. Okay. Now let's see an overview of what we have learned till now. So what we have learned as student is, first thing we learned that where given two non-empty sets A and B, the set of all the ordered pair where X belongs to A and Y belongs to B is called Cartesian product. Correct? Okay. So A cross B where A is this and B is this. So A cross B is this and B cross A is this. Okay. Both are different. So two ordered pairs are equal if and only if first element is equal to the second element. What do you say? First elements are equal of both the ordered pair and second elements are equal to the other ordered pair. Means X is equal to U and Y is equal to V. Okay. If the number of elements in A is P, number of elements in B is Q, so the total number of elements in A cross B is what? P into P cross Q or P into Q. That's it. Now, if you are taking a same set A and we are multiplying it, we are doing a cross product of that, a Cartesian product of that, then what we are getting? A triplet A, B, C, okay, where both A, B and C are all three belonging to the same set A, okay. So this is the general overview, okay. Now let's see a question and we'll understand more better how to do it. So the first question that we have is, let's say A is equal to, we have something like 1, 2, 3, 4, 5 and 6. Now they're telling that you're defining a relation from A to A. The relation is from which one? The first set is also A and the second set also A. The first set is also A and the second set is also A. And the relation is following a condition R is equal to X comma Y such that Y is equal to X plus 1. Y is what? 1 bigger than X. So let's make it A this side also, A this side also. Correct. So what we have in A? 1, 2, 3, 4, 5, 6. And B 1, 2, 3, 4, 5, 6. So if I'm putting X equal to 1, why what I'm getting? 1 plus 1, that is equal to 2. Correct. So X is coming from the first set and Y this one is coming from the second set. So 1 is getting matched with 2. And here this matching strength, understand this, we have a particular name for this. Okay. So what is the name is here? This 2, we say 2 is the image of 1. What do we say? 2 is the image of 1. And we say 1 is the pre-image of 2. So what we say? 1 is the pre-image of 2. Okay. So very simple. Understand, whenever we have 1 comma 2 linked, so we say 2 is the image of 1 and we say 1 is the pre-image of 2. So that is clear to everyone. Okay. Now if I put X equal to 2, I'll be able to match with 3. So again we can say 3 is what? The image of 2 and 2 is what? The pre-image of 3. Okay. So we got one relation as 1 comma 2, the other relation as 2 comma 3. Now the other, when we put X equal to 3 here, So what do you get? Y is equal to 4. So 3 comma 4. Again 4 is called the image of 3 and 3 is the pre-image of it. 4. So now next we have 4 comma 5 if you put, and next similarly 5 comma 6. So these all are the relations that we are able to find. Now what we'll see is we need to write down what is the domain. Okay, just now we said the elements which are coming from the first set. So what are the domains here? 1, 2, 3, 4, 5. So what are the domains here? 1, 2, 3, 4 and 5. For this relation, the elements which are coming in the first part, 1 or from the first set 1, 2, 3, 4 and 5, which is participating in the relation. Okay, since we have already gave a condition that anybody which is following this condition, that can only make a relation. Earlier it was every ordered set was a relation. Now we give a specific condition. If you follow this condition, you are in a relation. Correct? Now, so we got the domain. Okay, students, very simple. We got the domain. Domain is nothing but the first elements. Okay, 1, 2, 3 in a Cartesian product. The first elements are the domain. Or we also see sometimes as input. Okay, the one we are putting here. So when you're putting x, we are getting the y. So the first element here, x, is the domain part. Now what about the range? Now the moment we put domain, the corresponding values that we get, for 1 we are getting 2, for 2 we are getting 3, for 3 we are getting 4, for 4 we are getting 5, and for 5 we are getting 6. These values are known as the range. So for the given input, whatever the output you are generating, student, that is known as the range. That is known as the range. Now here comes the next question. Then sir, what is the codomain, sir? Okay, codomain is nothing but the entire B set. Whether it is participating or not, the entire B set is known as the codomain. So codomain is nothing but the entire B set, that is equal to 1 comma 2 comma 3 comma 5 comma 6. So everybody now they are familiar with this. What is range? So they gave the relation. In this relation they gave first they gave two sets A and B. Oh, sorry. 1 second, student. They gave both the sets are A and A only. Okay, they gave us two non-empty sets A and A, and they said that relation is defined by this condition x comma y such that y is equal to x plus 1. Okay, so x elements are nothing but they're taken from the first set A, and y elements are taken from the second set B. Okay, now when we are substituting x equal to the first element which is in set A 1, we were able to get 1 comma 2. So we said that the matching was there between 1 and 2, and 2 was called the image of 1 and 1 was called the pre-image of 2. Till now this much is clear. After that what we had is the elements, after getting the whole relation, the elements which are the x elements or the input elements were known as the domain, and after putting that input, whatever the output elements we got, they were known as the range. Okay, so once we got domain and range, we wanted to know what is the codomain. The entire second set A is known as the codomain. Clear till here, students? I don't think so. Now anybody will have doubt. If you still have doubt, you can put up in the comment section. You can join our WhatsApp group. Link is given in the description below. Okay, and you can also put your doubts in the website. That link is also given in the description. Okay, so we can schedule a doubt class and we can clarify all your doubts. Okay, so don't worry about it. Work hard, work smart, and don't worry. Now a good question comes, student, is finding the number of relations, because in case the number has a good value. Okay, so let's say what they have given is A is a set containing 1 and 2 element 1 and 2. B is a set containing 3 and 4. They're telling that find the number of relations from A to B. Okay, so the number of relations from A to B we have to find. So what we'll do, first we'll do A cross B. So if I do A cross B, student, what are the elements will be? 1 comma 3. Now we'll say, sir, here since no condition is there, so we'll do that, just a matching, normal matching with everyone. Each and every element of A will be mapped with every other element of B. So 1 is mapped with 3 and 1 is mapped with 4. 2 is mapped with 4 and 2 is mapped with, 3. So if we can say here again, That 3 is the image of 1, 4 is the image of 1, 4 is the image of 2, and 3 is also the image of 2. And vice versa, the pre-image we can say. Now, so the number of elements in A cross B is how much, students? That is equal to 4. So we know the total number of subsets will be what? 2 power 4. Okay, so number of subsets formula is what? 2 power the number of elements, correct? So since the number of elements are 4, so 2 power 4, and we know the number of subsets is equal to what? Number of relations also. Correct. The number of subsets is equal to the number of relations. So don't forget, very simple question here. Now if they give you a tricky kind, okay, what they say that is, instead of giving you random values, okay, so instead of giving you random values, they started giving you x, y in the form. So the number of elements in A they gave you as x, and the number of elements in B they gave you as y. Now they are telling you to find the number of relations. Okay. Or correct. So what we gotta do? First we'll find what is A cross B. The total number of elements in A cross B will be what? X into Y. So the total number of subsets will be what, students? The formula is 2 power the number of elements x, y. So the whatever the number of subsets will be, same number of relations will be there. Correct. Same number of relations will be there. That's pretty simple. So everybody got the concept. What is Cartesian product of set two sets? And from there, what is a relation? What is a domain, codomain, and what is a range? And along with that, how many number of relations we have. Clear? So very simple formula. This is very important, students. If you have any doubt, put it on the comment section. Okay, put it on the WhatsApp group. Join our WhatsApp group, and the Telegram link will also be given. Join that. PDFs and everything will be given. DPPs will be given in the Telegram link and the WhatsApp group. Okay. Now, so let's recap the domain and range. Let's say we have a set A, which is matched with, or which is having a doing of what is a Cartesian product with B. So what is the domain? The elements of A which are participating in the relation. Domain is nothing but elements of A participating in relation. Participating in relation, correct? Or the input ones. Whatever we are putting as the input. Now what is the codomain? Codomain is basically all possible values, that is B set. All possible value, okay, or you can say full set B. Now what is range, friends? The ones which we are getting output, okay, the ones which we are getting output. So we'll take some example, 1, 2, 3, 4, 5 and 6. Here 3, 4, 5, 6, 7. So let's say this is matched to this, 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 and this also matched to this. So what you can say, the domain will be all the elements of set A. So all set A. The range will be the output we are getting, students. So 3, 4, 5, 6. That's it. Because 7 is not mapped. Okay. And the codomain will be all possible values. So set B, that is equal to what? 3, 4, 5, 6 and 7. So nothing to be afraid of in this chapter. Pretty simple chapter it is. Okay. Now, let's see the next graph, y is equal to mod x. Now, this modulus function is very important for KCET student. Okay. So, modulus function, what does it mean? Y is equal to fx is equal to mod x. So, what do you basically understand by this? So, fx is equal to, this function behaves like x when x is greater than or equal to 0. If it is a positive quantity, what the mod does? It just brings it out as it is. Now, if it is a negative quantity, what it does? It puts a minus sign and prints it out. Okay. So, only thing is we need to understand is whatever comes out of the mod is always positive. That is one thing. So, if it is a negative number, how can you make it positive? By putting a negative in front of it. Correct. That's the basic idea. Yes or no? So, you already are negative. So, if we put one more negative in front of you and we say negative and negative cancels each other, okay, so what will happen? You'll become a positive person. Correct. But that doesn't happen in reality, student. Okay. So if you are already depressed and somebody comes up and makes you more depressed, so you go in a depressing, like hell kind of depressing state. Okay. So that doesn't happen. Now, but in maths it happens. So if you are already negative and when we are bringing a negative number, we are attaching a negative number in front of you. So what will happen? You will become positive. So how is the graph you have to draw? For x greater than 0 to, what is it, this side, okay, it is like y is equal to x. For x less than 0, the negative part, it is minus x. This is y is equal to minus x line, and this is y is equal to x line. Now you see, sir, what about the domain element? Pretty simple. Domain is nothing but all values of x. So everything we are putting in x, correct? We are putting every value in x. So the domain is what? All real numbers. But what about the range, student? Are we able to get every value in y axis? No. So the minimum value that we have of modulus is what? It starts from 0. Maximum in the positive case is infinity, but the minimum it can go, that is 0 only. Okay? Even whatever biggest negative number you bring it, you put it inside mod, it will give you a positive number. And the minimum number, the positive that we'll get out of the mod is 0. Let's see the next graph, which is very important. Y is equal to signal x. Now this graph, what we need to know about this is, first we need to know the function fx is equal to, how does it behave. Fx is equal to 1 when it is greater than 0, okay, and it is 0 when x is equal to 0, and it is minus 1 when x is less than 0. So signal function is basically student mod x by x. Now it says, sir, when x is greater than 0, when x is greater than 0, so what happens? Mod x will open as x, so x by x will get as 1. When x is less than 0, mod x will open as what? Minus x. Correct. So minus x by x is equal to minus 1. Correct. And for 0, they define it as 0. So what will be the graph? For 0, it is 0, students. Okay. For values which is greater than 0, it is 1. Okay, and for values which is less than 0, it is minus 1. So it is just taking three values. Okay, so the domain is what? You're putting all real values of x, but the range is, we are just getting three values in y, that is minus 1, 0 and 1. Understood? Any doubt, you can put in the comment section. Okay, we'll try to address the doubt. So what we have done here, signum function is nothing but mod of x by x. So when x is greater than 0, mod x will open as x. So x divided by x will be what? 1. When x is less than 0, just now we learned in the properties of the mod that when x is less than 0, it opens at what? Minus x. So minus x by x is equal to what? Minus 1. Correct. And for 0, it is 0. So done. That's it. For any value, let's say you are putting 2. So it will be mod 2 by 2. So that will be equal to 1. If you're putting 5, so mod 5 by 5, that will be equal to 1. Correct. Now you put, so let's put some negative numbers. Okay, mod minus 3. So by 3, so that is equal to what? Minus of minus 3 by minus 3. So this and this is gone. So minus 1. Correct. Clear. So we got the concept very clear. Still, if you have doubt, put it in the comment section, students. Now the next part of the graph is very, very, very important. This is graph is known as GIF. Okay. Now what is this GIF? This is greatest integer function. What is this? Greatest integer function. Now the moment you see, by listening to this word, greatest integer function, what comes in mind? Okay, whatever the value we are putting in, will be getting a greatest value, but it works opposite, student. What it does? It works opposite to its name. A lot of times we have seen students, okay, the name is like very courageous, very bold, but they are what? Just opposite in nature. Similar to that, we have here, okay. The name suggests that it is the greatest value, it gives the greatest value, but it always gives the lowest value. So let's see how we get the lowest value. So in the greatest integer function x, what we have to see is, here in this case, let's say it is denoted by this box, okay. So let's say we have box x. Let's put some values first to understand the graph. Okay, first to understand the function. Let's say we have a value 5.2. Now you see, sir, by the understanding of the name greatest integer function, it will give you the greatest integer. So now this 5.2 is made from two integers. It is lying between two integers, not made lying between two integers. One is what? 5. One is what? 6. So it should choose 6, correct? So it should take 6. No. So it will always give the lowest integer nearest to it. Okay. So it always gives the lowest integer. So 5.2, if you do the box of 5.2, you'll get what? 5. Now coming to one more value, let's say 1.9, sir. What about 1.9? Very near. A lot of students, they go by the logic. So since 5.2 it was near to 5, so that's why they gave 5, sir. Okay. So what about 1.9? Again, it is nearest to what? 1 and 2. But since again I told you, it works just entirely opposite of its name. So 1.9 will be given as what? It will be selected as the box of 1.9 will be 1 only, student. Don't mark it 2. You'll be getting a laddu. Okay. So understand it. So the name greatest integer function works exactly opposite, and it works like a lowest integer function. Okay. So how do we define it as? So box x equal to 1 when x is between greater than 1 but less than 2. So any value 1.9, if you see, it is greater than 1 but it is less than 2. So what will be the box 1 value? 1. So how do we draw the graph? Let's see in the next page how to draw the graph. So this part everybody is clear. Now what about a negative value? A lot of people, they are concerned about the negative value also. So let's see the negative value. Let's say we have a value, what do you say, uh, 0.9 minus of 0.9. So it is lying between two integers, minus 1 and 0, correct? Now, if we are going by the name greatest integer, it should choose 0, but no, it does opposite to that. So the value will be what? Box of minus zero point 0.9 is what? It will be minus 1. So whenever the box is greater than equal to minus 1, but less than 0, the box value comes out to be as minus 1. Clear, students? Let's see how do we draw the graph. So values from 0 to 1. Okay. Greater than 0 but less than 1. So it will be here. Greater than 0 but less than 1 is 0 only. Correct. Whenever x is greater than equal to 0 but less than 1. So lying between 0 and 1. So what will you choose? The smallest integer. Between 1 and 2. Between 1 and 2 it will choose what? The smallest integer 1. Between 2 and 3. It will choose the smallest integer 2. Same thing for the negative. Between minus 1 and 0. What it will be choosing? Correct. Minus 1. So same like this. Okay. Done. So what about the range and domain? So let's first see domain. So domain is, we are putting every value here. Correct. We are putting every value of x. Correct. There is no restriction in the values of x. So domain is all real numbers. Correct. There is no doubt about that, all real numbers. Now, what about the range? In range, if you see, it is not taking any non-integral value. Non-integral means what, student? Non-integers. It is just taking integer 1, integer 2, integer 3, or minus 1, minus 2, minus 3. So it just takes only integral values. So all integral values, it takes integral values. Okay. So from what is a negative 0 to all positive integral values, it takes. But it doesn't take any value between any integers. Okay. All integral values, it takes it up. Okay. So any doubt, student? You can put it in the comment section. Okay. Now let's see a bit about power function. Okay. So when we have even powers, okay, when we have even power, like y is equal to x square, x power 4, x power 6, dot, 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 the graph is similar to this. Okay. Now, what if we have odd powers? Whenever we have odd powers, the graph is similar to this. Y is equal to like x cube, x power 5, x power 7, like that. Okay. Now, what about inverse? Okay. Negative and what you say, let's say we have what you say values like what you say y is equal to x power minus 2, means 1 by x square, reciprocal of even powers, 1 by x square, 1 by x power 4, 1 by x power 6. In this case, it will be like this graph. Okay. Now it is very simple. You can put the values and you can plot it. Okay. Now what about for odd powers? It will come in one positive axis and one in the negative quadrant. Okay. So for negative powers like y is equal to 1 by x, reciprocal function, 1 by x cube, 1 by x power 5. Okay. Now what about the range and domain? So you can see domain is what? All real numbers. And if you can see the range is what? All positive values, so 0 to infinity. If you see here, domain is also R, range is also R. If you see here, domain is equal to all real numbers minus 0, because we can't take 0, and range is also what? From 0 to infinity. We're not taking 0 also, it is not touching 0. Here also again, if you see, domain is what? all real numbers except 0, because we are not taking this value, and range is also same thing, all real numbers except 0. Okay, so if you know this much of graph, and you'll see when we'll be solving the PYQ and the exemplar section, it will be very easy to put the question in the graph, and it will just take 5 seconds to solve the question. And this timing, whatever extra you are able to save here, you can put it into the calculus and other parts where you really have to, do a lot of working. Okay, now let's see the 12th class of, or the second PU of relation and function. Okay, we are already done with the first PU of relation and functions. We understood what is basically sets. We understood what is the Cartesian product of sets. From there, we got the idea of relation. Then a relation following certain conditions became a function. Then we read about some specific kinds of functions. We learned about the domain and range of those functions. Now we are coming to the 12th topic, or the second PU topics of relation and function. Okay, so first we'll read about types of relation. What we'll read about? Types of relation. In the types of relation, first is void relation. Okay, after that void relation, we have universal relation. Now, what do you mean by void relation and what do you mean by universal relation? Okay, so very simple, students. Void relation means what we know, phi is a subset of every A cross A. Correct. And if we take A cross A, will have to be a subset and what is equal to A cross A. Correct. So this becomes a universal relation for A cross A, and phi becomes a void relation for A cross A. Clear. So that is pretty simple thing. Now, most important, here we need to understand what is reflexive, symmetric, and transitive. Okay, so reflexive, symmetric, and transitive, student, you need to understand what is it and what do you understand by it. So that is more important. Now, students, let's see the different types of relation. The first relation that we have is void relation. What is basically a void relation? It's basically empty relation. If no element is related to A cross A, okay, no element is related to any other element of A, then we can say that is a empty or void relation. Now, if each and every element is related to the set, then we say it is what? A universal relation. Now, next three kinds of spatial relations will be reading. One is reflexive, one is symmetric, one is transitive. So, if we know that if A belongs to, set A, and A comma A is related to R, it's related to the relation, then we say that it is a reflexive. Now this word A comma A related to R, it sounds too cringe, like we're not able to understand what they're trying to say. Okay, so let's understand with simple examples. What do you mean by a reflexive relation? Reflexive means what? Your own mirror image, you can say. Reflexive means what is, if A is related to some relation, A by certain conditions, A comma A also has to be related by that condition. So now we'll say house. Okay. So let's say a relation is parallel to, for a line. We have a line and we have put the condition that is parallel to. If somebody is parallel to, then it that is the condition for the relation. So we know a line L1, is it parallel to itself? Correct. So we can say that it is reflexive. Okay, the relation is parallel to is reflexive. Now, second thing, what we can say, we can take simple other examples. Let's see. What we can say is, let us take an example. A relation given by is divided by. Okay, is divided by. So any number you take, let's say A, you have taken a number. Any number is divided by itself. Yes or no? Yes, correct. So that is also a relation, students. Correct. If you understand the reflexive, what is called, what is a reflexive relation is basically, if A comma A is related, belongs to R for every A belongs to A. So let's see a very simple relation we'll be able to understand. Or like we can take a relation is congruent. Okay, we can take a relation is congruent to. So we know, let's say we have taken a set of A is equal to set of triangles. We have taken set of triangles and set of triangles. And let's say uh, R is a condition we have put up is congruent to congruent to. So we know if T1 is a belonging to, if T1 belongs to A, then T1 comma T1 will be belonging to this condition R. T1 comma T1 will belong to this condition R. So what does it trying to say is every triangle is congruent to itself. So if something can be happened to that same thing, means if you are a element of a set and you are able to follow the conditions of the relation, that you are able to align with yourself, okay, then we say it is reflexive. Okay, means it is the image of yourself. So every triangle, if you put up superimpose on each other, so every triangle is congruent to its, correct. So that way we can say it is reflexive. What about symmetric? Symmetric is pretty simple to understand. Let's say let A comma B belongs to a relation, then if B comma A also belongs to relation, this is symmetric. Means if let's say we have taken a condition, for example, is brother to. So you are a brother to, let's say X is a brother to Y. So we can say Y in turn is also a brother to X. Yes or no? So similar, very simple. Okay. Symmetric means same thing. If I know that X comma Y belongs to R, and I can say that Y comma X will also belong to R, I can say this symmetric. What about transitive? Let's say A comma B is belonging to a relation and some other element B comma C is also belonging to another relation. Now by following these two, if I can say A comma C, if I can say A comma C also belongs to the relation, then we can say it is transitive. Let's see a simple example. Let's say T1 line is parallel to T1 is parallel to T2. Okay, so we can say T1 and T2. Let's say this is T1, this is T2, and we made a condition that T1 is parallel to T2. Okay, T1 is parallel to T2. Now the another condition we have taken, T2 is parallel to T3. Okay, so T2 line is parallel to T3. So can we say by these two, merging these two conditions, that T1 is parallel to T3? Yes or no? So that is transitive. Pretty simple, students. Okay. Now, if some relation is following, if any relation which follows, which is all three, then we say it is equivalence relation. What is it? Equivalence relation. Okay. Now, students, we read about different kinds of types of relations. Now, let's read about the different types of functions. Okay. So, the different types of functions. What are the different types of functions? Is first is one. So by the name, it is pretty simple. What does it wants to say? Means one value of x is related to one value of y. Means A is set one, B is another set, and f is a function from A to B. If each value of A is related to just one value of B, okay, then we say that it is 1, 1. Then we say that it is 1, 1. Okay. So very simple. Now, in order to prove in the question how we do, we just show that fx1 is equal to fx2 for all x1 belonging to equal to x2. That's it. Nothing is there in this question. The moment we'll take question, we'll be able to understand. This is to prove and this is the meaning. 1, 1. Okay. Now, it also has a special name. 1, 1 is known as injective function. What is it known as? Injective. Now, what about many one? The opposite of this, many one. Now, what do you mean by many one, student? Is more than one values of A is related to a value of B. Okay. So, 1, 2, 3. Let's say all these are related to A. So this is what? Many one. Many one means what? Many values of A is related to. See, you can say many means more than one, and one here is related to. So many values of set A is related to one value of set B. So very simple, by the name only. You don't have to understand. You don't have to mug up anything. So many means what? More than one value of A or set A is related to one value of set B. Okay, so that is known as many one. Here it is 1, 1. One value of A is related to one value, just one value of B. So that is 1, 1. Okay, pretty simple like this. Now, Now here, what's most important part is to find the number of one-one functions, which is basically mostly asked in the KCET part. So f is a function which is from A to B. Okay. So now the number of one-one functions will be how much? So number of one-one functions, number of one function. Now, what will be the formula of to find the number of one functions? It's pretty simple. That is equal to, now A has, let's say, m elements and B has, let's say, n elements. It is npm. Now we know permutation. So as of now, I'm just, what do you say, keeping it in mind that you know a bit of permutation. So it is npm if n is greater than m, and it is 0 if n is less than m. Okay, this is the formula I'm giving you, students. Okay, we'll see how we apply it in the, what is it, KCT questions, but these are the most important parts. Okay, so this kind of question you can expect each time: the number of one functions, the number of onto functions, or many one functions. Okay, so that we also will see. So one we got. Now coming to onto. What is onto basically? Function is, let's see, ONTO. Onto function is basically also known as surjective. Surjective function. Okay. Now what is this function, student? Surjective function is, this function says that, let's say we have 1, 2, 3, A and B, 4, 5, 6. So we have something like this. So here what you can see, the range is also what? 3 elements, and the codomain is also same. So when range and codomain are same, means there is no element left in set B which is alone or doesn't have a pre-image, then we say that it is onto. So what is onto, student? Each element, you can see each element of B has a pre-image in A. Okay. So we know each element, say 4 has a pre-image 1, 6 has a pre-image 6, 5 has, 3, 5 has a pre-image 2. So each element of B is related to some or the other element in A. So when this happens, the range is equal to the codomain, and then we say it is onto function or surjective function. Now, what is the number of onto functions? Very important. So number of, you have to mark up this value onto function. Proof is also there, but we will not do as of now in the crash part. A to B, m and n elements are there. So n power m minus nc1, n minus 1 whole power n, plus nc2, n minus 2 whole power n, minus nc3, n minus 3 whole power n, plus dot dot dot. Now you'll see, sir, the formula looks pretty big. Okay, how do we apply? Once we see it in the exam, we don't have to do like 2 to 3 steps. Max we have to do of the formula. So don't worry about that. While when we are doing the PYQ, we'll be showing you how to do it. Okay, you can go with this formula also. Sigma r goes from 1 to n minus 1 power n minus r, ncr r power n. So you can go with this formula also. Okay. Now after this, the next part what we have is composite function. Okay. Composite by the word means that one function is entered inside the other. Okay. So we have fog and golf. So what do you mean by this function? Okay. This basically means f of g, means f bracket gx. Means, see, when we had a function fx, what it means, in this function f, we are putting the domain, what is say, x. Now in this function f, we are putting the domain as, or the input values as gx. Okay. So g of f means in the function of g, we are putting the input or the domain values as of fx. Okay. So let's see one simple example we'll be able to understand. Fx is equal to tan x and gx is equal to x square. So if you do FOG, so it's basically in function f you're putting gx. So it's basically in function f you're putting, what is my gx? X square. So if I'm putting x, students, I'm getting tan x. If I'm putting x square, what will be the value? Tan of x square. That's it. Okay, nothing difficult. Now what about GOF? So that is equal to g of fx. So in the function of g, I'm putting fx. What is my fx? tan x. So if I'm putting in G x, I'm getting what? In return, output x square. So if I'm putting tan x, I'll get what? Tan x the whole square. So is it anything very difficult? No. Now for the inverse also we have a condition that what is the condition for the inverse? If fog is equal to GOF student, then we have if FOG is equal to GOF, then we say that the function's inverse is possible. It is invertible or inverses exist. Invertible or inverse exist. Okay. So these two we know. So if a function is either if we show fog equal to GOF or we show a function from A to B and G is a function from B to A, then inverse if it is 1, 1 on 2. So two conditions it has to follow. Either it has to be 1, 1 on 2. Okay. It is also known as bijective. Okay. Surjective plus injective. So both together is known as bijective. Or we can show if it is fog equal to GOF, then we say inverse exists. And G function is nothing but inverse of the F function. Clear? So very simple we have. While doing the questions in the PYQ and exemplar, will go in much more detail about this. Okay. In the PU and all, we had very greater length question like 5-mark questions and all that, and it comes every year. But here we are not going about that much in depth. We'll see how to solve the questions of fog and GOF or inverse in a much simpler manner when we'll be doing the PYQ section. Next is we'll read about binary operations. Okay. So next is binary operations, students. So very simple topic, binary operations. Let's see. So binary operations. So basically what do you mean by binary operation? Okay. So binary operation means what is, let's say we have a natural number, and on natural number we are performing an operation star, which means to add. Okay. Let's say we are doing a plus operation here in the form of star, which means we are adding up. So whenever we are adding two natural number, let's say natural number 1 and natural number 2, are we always getting a natural number 3, which is all, we are getting a number 3, which is also a natural number. So if this happens, we say star or the addition, okay, is a binary operation. Means whatever the input is, the output is coming to be same. Okay, in the same way. Now what about subtraction? You say we are taking a natural number n1 and we are performing a subtraction among two natural numbers. Now here, depending on which number is bigger, which number is smaller, we can get a negative number, and that is not defined in natural number. So we can say that a negative number doesn't exist in natural number, so it is not a binary operation. Pretty simple. Okay. Next we have a concept of identity element. Okay. It's very simple. Identity element, just like normally we understand A star E, we should get E star A, and that should be equal to A. Just like 1. Identity element is what? In multiplication case, 2 into 1, any number multiplied with 1 is equal to 1 multiplied with that number, that is equal to the number. So that is identity. Now what about inverse? So inverse is same thing, since E is acting as the identity like 1. So A star B, any number, if I'm doing the star of that, and if I'm able to generate E, so then we can say that B is inverse of A. B is what? Inverse of A. Clear? Now here one most important thing is, student, we should, what we need to understand is the number of binary operations. One formula, the number of binary operations. So number of binary operations, okay, the number of binary operations of set of m elements is equal to m into m square, m power m square. So this formula is very important, students. Okay, so we'll see what is a lot of cases where we'll be doing what is it, the questions based on this, and on the formula concept wise, these are more than enough for you to solve each and every KCET problem, okay, based on relations and functions. So that is more than enough. Okay, so work hard, make the notes, upload it, we'll go through, we'll check it, and we are working hard. We're trying to bring full whatever we have promised before the deadline day, so that you can revise, you can take your test, you can, what do you say, work hard on you. Do share this with all the people in Karnataka who are in need of it, or to all the students who really need of it. They don't have the resource to what do you say, get a good coaching or something, and they can excel in their, what do you say, KCET. So do share it. That is one big thing we want from you students, nothing more than that. So work hard. Best of luck.